So this is the ideal batch reactor. Ideal batch reactor means reactor for which feed and exit both are in batch form. This is a very important term. Reactor for which feed and exit both are in batch form. Here designing parameter is XA. Unsteady state reactor is the ideal batch reactor is the unsteady state behavior reactor. Why it is the unsteady state reactor? As here accumulation not is equals to 0. Why accumulation is not is equals to 0? If we see in the batch reactor, we can see there is in the t not equal t equal to 0 time feed is entered or feed is inject into the batch reactor. Ca naught is the initial concentration, and when it will be exit, there is a some conversion. Xa is there and Ca is the total concentration which will be in the exit term, which will be concentration, that is a Ca. Okay, and blue or this shaded form is here reaction will be held here, and there as there when exit, then the full product will be exited. So their accumulation is not is equals to 0. As accumulation is not is equal to 0 means Xa continuously increasing with the time. So as Xa not is Xa continuously increasing with the time, so it is the unsteady state reactor. Here ideal and perfect mixing is there. Always ideal and perfect mixing is there, and concentration is uniform throughout the reactor. Throughout the reactor, as concentration is uniform, so then we can say that throughout the reactor the reaction always will be there. So we can say mole balance reaction A to P in a reactor for batch reactor at time t with in the at time t within the reactors, that is the formula is that T is equals to Na naught 0 to Xa dxa by to the dxa divided by minus Ra into V within the reactors. Mole balance for a reaction A2 product in a batch reactor at time t within the reactors, that is formula is that T is equals to Na naught 0 to Xa dxa by minus Ra into V. That is the formula of batch reactor. So here this is the formula. T is equals to Na naught 0 to Xa dxa divided by minus Ra into V. Here this V term we decide that is the CVRS or this is the VVRS system. So formula is that T by Na naught is equal to 0 to Xa 1 by minus Ra into V into dxa. So what is the area? Area is equals to A to B y into dxa. A to B y into dxa. Y is equals to function of x is equals to 1 by minus Ra into V. So this is the valid for VVRS system, and this is the valid for VVRS and also CVRS system. This is the graph. In the graph in the y axis 1 by minus Ra into V, and in the x axis it is the Xa. Graph will be not start from the origin. Graph will start from difference from the origin. From there graph will be start, and this is the graph, and area is equals to T divided by Na naught. Okay. Here we can say slope will be depend on the particular reaction order, means N. This is the order, this is the minus Ra. From there we can see what is the order. So depend on the order graph. Slope will be depend on the particular reaction order. So these are the point. First point is the valid for both VVRS and CVRS system. Second point is area of performance curve should be minimum. Area of performance curve T by Na naught will be minimum. Curve will not start from the origin. That is a very important point. Curve will not start from the origin, and slope will depend on order of reaction. Here slope will be depend on order of reaction. This is the order of reaction in or minus Ra. From there it will be dependent.